Today we're going to spend some time learning how to do a quick graph using our x and y intercepts. There are two quick graph methods, but today our focus is on the intercepts. We've already learned that we could set up a table of values and graph those ordered pairs, but we only need 2 points in order to graph a line, so we're going to find it useful to explore the x and y intercept method. If our equation is in standard form, the ax plus by equals c, where a and b are not both equal to 0, we can then use these 2 points in order to graph. Simply state a point that falls on the x-axis. So let's take a point right here. This would be -2, 0. And perhaps a point right here, which would be 0, 3. There are 2 points. The x-axis is our -2, 0. Our x-intercept falls there. And my y-intercept is this point right here that falls on the y-axis. I have 2 points. I have the graph of a line. Sometimes you'll be actually given the x and y intercepts. Can't get any easier than that. Other times we may have to do a little work to find out what those intercepts are. So again, that y-intercept is the y-coordinate of the point where the line intersects with the y-axis. X-intercept is that coordinate of the point that falls on the x-axis. So what will we need to do? If the equation is not in standard form, we must first write it in standard form. There is just a simple way to do that. To find the x-intercept, we'll let y equal to 0 and solve for x. That'll help us to find the point that falls on the x-axis. And we'll do the reverse. To find the y-intercept, we'll let x equal to 0 and solve for y. Once we have those 2 points, we draw our line through it. Now, before we even get to that, let me just demonstrate what it looks like without having to change or look for anything. Let me pull up a graph, and let's look at this in a simpler form first. Okay, so here's my coordinate plane. What if I told you that my x-intercept equaled -3 and my y-intercept equaled 4. Well, an x-intercept is a point on the x-axis, so that tells me that that point is -3, 0. So to plot that, I go to the origin and I count over 1, 2, 3 places in the negative, and because it doesn't go up and down, or up or down, that's my point. It's the x-intercept. The y-intercept is a point that falls on the y-axis where x is equal to 0. So now I simply go 1, 2, 3, 4, and I connect my points. When we don't have anything to do, that's all there is. If they just give me the points, then I'm good. Let's just do one more like this so you just get the hang of it. We'll try an additional one. Let's change up these numbers on the second one now. Let's take this graph off and we'll start again. What if my x-intercept was 5 and my y-intercept was 2? This 5 is telling me that I'm going to go to the point on the x-axis 5, 0. Because if I count over 1, 2, 3, 4, 5 on my x-axis, that coordinate would be 5, 0. If it's telling me my y-intercept is 2, which falls right there, that tells me that that is 0. 2 is my coordinates. So now I have my 2 points, and all I need to do is connect those 2 points, and there's my graph. Now, of course, life is never as easy as that, so you know that we have to do a little work to find our intercepts. Let's try our first problem. Given an equation, first of all, we have to see if it's in standard form, and this one is in standard form. It's in the ax plus by equals c form. So what are we going to do? We're going to find our x-intercept by setting y to 0. I've already set it up here. I take the original equation, I replace y with 0. I now will solve for x. This leaves me with 2x is equal to 12. Divide by 2. I get x is equal to 6. So it's telling me that x, count over 1, 2, 3, 4, 5, 6. There's my x-intercept. It's at 6, 0. Now I want to find my y-intercept, so I'll do the reverse and I'll set x equal to 0. That cancels out that term. I'm left with 3y is equal to 12. One inverse operation, and I get y is equal to 4, which means that I'm going up 1, 2, 3, 4. There's my point, which tells me that coordinate was 0, 4. And again, all I need to do is connect the points. Quick graph. I'm not plotting a whole lot of points. All I need was 2. How do I do that? By setting one of the variables to 0 to solve for the other. Next problem. 2x plus 4y equals 8. It's in standard form. What is standard form? Some constant times x plus some constant times b equals some constant. So I need to find my x and y intercepts. It doesn't matter which one we solve for first. If I want to solve for x, set y equal to 0. That means I'm just taking whatever number it is and multiplying by 0, which basically cancels it out. But I'm going to, for the first couple examples, to show you exactly what I'm doing. I'm taking y out and setting it equal to 0 by multiplying it by 0. It will cancel out because anything times 0 is 0, leaving me with 2x is equal to 8. One inverse operation, x is equal to 4. Let's go to our graph and go 1, 2, 3, 4. There's my x-intercept. It was at 4, 0. Now let's find the y-intercept, and this time we'll set x equal to 0. So that gives me 2 times 0, which again cancels out, plus 4y equals 8. 4y is equal to 8. Divide by 4. You get y is equal to 2. I'll go 0, 1, 2. There's my second point, and we connect the dots. Okay, so quick graph. It doesn't take much to do this. I believe I have at least one more example. Okay, once again, we're given the equation in standard form. Let's find the x and y intercepts. Let's set y equal to 0. 3x minus 2y. And again, this middle step here, you probably can just go right into 3x is equal to 6, because we know this will cancel out. To 0 was my x-intercept. Now let's do it where we set x equal to 0. And again, I mentioned that this step probably can go right into negative 2y equals 6. Divide by negative 2. And y is equal to negative 3. So now I have my y-intercept. 0, negative 3, 1, 2, 3 down, and connect. And there you have our x and y intercept quick graph. We'll do a little practice for our assignment today and bring questions to our next class if we need to do more.